Hello, and today I'm going to be going through the Mathematics Numeracy Unit 2 Calculator Allowed Higher Tier paper from the WJEC, which was set in June 2023. So we can see that there's 10 questions, totaling 80 marks, and you're allowed to use a calculator. For pi, we can either use the pi button or 3.14, and in the space provided. And we have the usual formula sheet with area of the trapezium, volume of a prism, surface area and volume of spheres and cones, the sine rule, cosine rule, and the area of a triangle, the quadratic equation, and the AER equation. So, question 1. This is one where we're going to be assessed on your organisation, communication, and accuracy of writing. So, Southend Pier is the longest pleasure pier in the world. It is 1.34 miles long. Gareth walks at a steady pace along the pier. He covers 84 metres every minute. He starts walking the length of the pier at 2 p.m. What time does Gareth reach the end of the pier? Give your time correct to the nearest minute. Okay, so first of all, looking at this question, Gareth is walking at a rate of metres per minute, but the pier is in miles. So the first one we need to do is convert, let's get the pen operating. So first thing is convert 1.34 miles to kilometres. And to do that, we need to times by 1.6. So we have 1.34 times 1.6. I'm going to put that into the calculator. So that's going to give 2.144 kilometres. And now I'm going to convert that to metres by times in by 1,000, so that's 2,144 metres. So if he's walking at 84 metres a minute, if we divide 2,144 by 84, this is equal to 25.5 minutes. Therefore, Gareth will get to the end of the pier at 2:26 p.m. Right, the table below gives the height of 27 musicians in Camwen Youth Orchestra. In which group does the median height of the musician lie? You must give a reason for your answer. So the median height is the middle person. So there's 27 people. So the median person is the 13th and a half person. So I'm going to say that this is in the 166 to 174 because these two add up to 13. So the reason is we are looking for the 13.5th person, therefore round up to 14 for the 14th person. Another way of looking at this is because there's overlap of the 166, they could be in both groups. Is it certain there is at least one musician in the orchestra who is less than 1 metre 54 tall? Give a reason for your answer. And we can say no because we do not know how the 3 people in the group are distributed, i.e. they could all be 157 centimetres, for instance. Calculate an estimate of the mean height of a musician in the orchestra. So the way I like to do this is I find the midpoint of each of these. So that's 154, 162, 170, 178, 186 and 194. And then we multiply by the frequency. So we got 1 times 194, so that's equal to 194. This one's equal to 0. This one's equal to 1620. Then we have 3 times 154, which is 462. 9 times 170, which is 1530. We have 178 times by 4, which is 712. And then we're going to sum all of these up. So we got 462 plus 7620 plus 1530 plus 712 plus 194. And that all totals 4518. So I got 4518, and I'm going to divide that by the number in the orchestra, which is 27. And that comes out on the calculator to 167.3 recurring centimetres. So Layla has been set a target by her fitness trainer. Every day she has to increase the number of steps she does. Today Layla did 1,800 steps. Calculate the number of steps the trainer is expecting Layla to do on the last of these 28 days. So what we're going to do is, because we have 2%, this is equal to 0.02. Because it's increasing, we can write that as 1.02. So we can put our 1800 multiplied by 1.02 to the power of the number of days, which is 28, because effectively we're adding the 2% on each day, and this is the formula for it. So again, I'm going to put that into a calculator, and that comes out as 3,134 steps. Paper comes in standard sizes. Which paper size is approximately 500,000 millimeters squared? Circle your answer. So first thing to notice is that they've given you the lengths in centimeters squared. So we have to move this decimal point one place to the right in all of these. So we can just go through and do 1189 times by 841, which is 99,000. No, it's not. It's 999,945. So we're looking roughly for half of that, which is the A1 size, and we can check our answer by doing 841 times by 594, and that comes out as 499,554. The mass of paper is measured in grams. The quality of paper is given by its mass per square metre of paper. Calculate the quality of a sheet of A2 paper used for printing is stated as 120 grams per metre squared. Complete the following statement. This sheet of A2 paper has a mass of blank grams. Okay, so first of all, we're going to have a look at the A2 piece of paper, which is going to be 59.4 centimetres by 42 centimetres. So I'm going to convert this to metres because we need to work in metres squared. So this is the equivalent of 0.594 metres times by 0.42 metres. And therefore that is equal to, I'm just going to put that into a calculator, so 0.594 times 0.42 is 0.249 metres squared. So now we need to find out what the grams are. So if this is the area, we've got 20 grams per metre squared. So if we times by 0.249 metres squared, this metre squared will cancel with this metres, which will give the final unit of grams. So we've got 120 times 0.249, and that comes out as 29.94 grams. Right, a sheet of A4 and A5 paper are mathematically similar. Calculate the length of the diagonal of the A5 sheet. You must show all your workings. So first of all, we will calculate the diagonal of the A4. And this is done via Pythagoras, because we now have a right-angled triangle. So we're going to say that x squared is equal to 21 squared plus 29.7 squared. So which is equal to 1,323.09. And I'm going to square root the answer to find x. So x is equal to the square root of x squared, which is equal to 36.37. So next up, I need to find the scaling factor. And I'm going to do that by dividing 21.0 by 29.7. So that's equal to 0.70 recurring. So if I multiply my x by the scaling factor, this will equal the diagonal of A5. So I'm going to times that by 36.37. And that comes out as 25.7 centimetres. Should probably put the centimetres in there as well. The measurement of the A1 sheet of paper in the table is correct to the nearest millimetre. Calculate the greatest possible perimeter of an A1 sheet. Okay, so we're going to need the biggest possible numbers. So that's going to be 84.15. And we're also going to have 59.45. So to find the perimeter, we have to add 2 of the 84.15s to 2 of the 59.45s. So you've got 2 times 84.15 plus 2 times 59.145, and that comes out at 287.2 centimetres. And we can also check to see if that's reasonable, because we've got roughly 160, 170 added to another 100 and another 120, which is approximately 290. Right, the cost of sending a package depends on the volume. And then we've got a table of different volumes. A rectangle handle with care label is stuck to the package. The label measures 17.5 centimetres by 11 centimetres. The package is a cuboid with a height of 19 centimetres and a width of 6.75 centimetres. Each vertex of the label touches the edge of the front side of the package. Calculate the volume of the package, hence find the cost of sending the package. Okay, so what we have here is basically 2 triangles. So to find the volume of the overall package, we need to times, I'm going to call this L. So the volume is equal to 6.7 times 19 times by L. And we don't have L. So I'm going to call this length here Y, X, and this length Y. So L is equal to Y plus X. So I now need to find Y and X. So first of all, I'm just going to sketch out this triangle here. So we have an angle of 34, 17.5, and we have X down here. I'm going to label this up as H. There's my right angle, so this is the adjacent. So I'm going to use my trigonometry. So cosine 34 is equal to X over 17.5. So this gives X is equal to 17.5 cosine 34. So I'm going to put that into a calculator, making sure the calculator is in degrees mode, not radians. And that comes out as 14.51. So I'm now going to draw out the triangle with Y in it. So this was 56, and we're told that this is 11. So again, this is a similar example. So we have cosine of 56 this time is equal to Y over 11.1. So we've got 11.1 cosine of 56 is equal to, and again go into the calculator, 6.21. Therefore, L is equal to 6.21 plus 14.51, which is 72 centimetres. So now we can calculate the volume by substituting in. So we've got 20.72 multiplied by 19 multiplied by 16.7 is equal to 2637.3 centimetres cubed. So we're now looking to see what lies between 2000 and 4000. So cost is £14.85. And they've asked us to fill in the answer down here. And always remember the units. So Delta Metals make aluminium chimes in the shape of an open cylinder. Each chime has a height of 2.5 meters. The external diameter of the chime is 0.8 meters. Calculate the external curved surface of the chime. Give your answer to three significant figures. So we have effectively a cylinder that looks something like that. That's badly drawn. Let's try that again. Okay, that's better. So the external area can be written as a rectangle with the circumference times the height. So if we unwrap this cylinder, it becomes a rectangle. So the circumference is equal to pi d, which is equal to pi times 0.18, which is 0.5655. And we're going to times that by the height. So area is equal to C times height, which is 0.5656 multiplied by 2.5 is equal to 1.41 meters squared. Okay, the frequency table below shows the monthly rainfall for Polfestwyn for a 5-year period from January 2010 to December 2014. And they're asking us to find the frequency density. So for this, what we are going to be doing is taking the number of months and dividing it by the interval of the rainfall. So we can test this by seeing that the first one has a number of months of 6. So if we divide it by the interval, which is 0 to 50, so that's an interval of 50, we get 0.12. If we take the next one, which is 10, and we divide it by 25, we get 0.4. So we can check that we're doing the right thing. So the next one is also an interval of 25 and a number of months of 10. So that again is 10 divided by 25, so that's 0.4. We then have 7 divided by 25, which is 0.28. 12 divided by 25, which is 0.48. And then we have 8 divided by 50, which is 0.16. So just being careful that when you see the intervals change. And then we finally have 7 divided by 100, which is 0.07. And then they ask us to complete the diagram below. So we need to go to 0.4 and another barrier of 10. So in an exam, you'll be able to do this far more neatly, I can, on this tablet. Next one, we need to do an interval. An interval of 25 again. This time is 2.8. Then we got another interval 25, and this time we're going up to 4.8. So and then we've got interval of 50 going to 1.6. And finally 0.7. A wet month is classified as one where the monthly rainfall is greater than 60 millimetres. Calculate an estimate for the percentage of wet months in Paris in the 5-year period. You must show your workings. Okay, so we know that there are definitely all of these are have more rain than 60 millilitres. So we're going to be doing 10 plus 7 plus 12 plus 8 plus 7. So that's equal to 12 plus 8 is 20. Add the 10 is 30. So 44 is the number of months when there was more than 75 millilitres. So now we have to try and take a guess of how everything is distributed between these numbers. This 10 is distributed between 50 to 60. So what we can do is we can divide it into 5. So we can do 10 divided by 5 is 2. So that's what we can subsection it up into. And therefore, for 50 to 55, there would be 2. For 55 to 60, there would be another 2. So that's 4. And then the remaining 6 would be above. Therefore, 55 to 60 would give 2 months. Therefore, 60 to 65 to 75 would be 3 months. So we have 44 plus 6 is equal to 50 months as an estimate. Right. Central pivot irrigation is a method of watering crops. The sprinkler arm, supported by wheeled towers, rotates around a central pivot. For each complete rotation, the water region forms a circle shown below. A typical central pivot irrigation system waters in a circle radius of 400 metres. The sprinkler arm rotates 30 degrees in an hour. Calculate the area that is watered in 1 hour. So I'm just going to draw a little area saying 30 degrees and say that this is the area watered in 1 hour. So the area of a circle is pi r squared. The area of this segment is going to be times 30 over 360. So we end up with pi times by 400 squared. So 30 goes into 30 once, 30 goes into 360 12 times. So we're going to find that by 1 over 12. So putting this into the calculator gives pi times 400 squared divided by 12 is equal to 41,887.9 meters squared. Right, the outer tower is 400 metres from the pivot. During one watering session, the outer tower moves 1,067.6 metres. Calculate the angle the sprinkler arm has turned through. So effectively, we have a section of a circle which looks something like this. We'll call that angle theta, and this length here is 1067.6, and this length is 400. So 2 pi r is the circumference of a circle, but we're going to be calculating the arc length. So we need to times that by theta over 360. So we've got, this gives 2 times pi times 400 times by theta over 360 is equal to 1067.6. So this is 10,067.6 divided by 2 pi times 400 times by 360 is equal to theta. And if I put that into the calculator, so I'm going to put on the top 1067.6 times 360, and I'm going to divide that by, in brackets, 2 times pi times 400, and that gives us 152.9 degrees. The part of the sprinkler arm furthest away from the pivot delivers water at a faster rate than the part of the sprinkler closest to the pivot, given the reason the system has been designed this way. It's because the further out, the larger the arc travelled. Therefore, you need to deliver more water because you need to still deliver the same amount of water per metre. So the outer sprinkler travels a greater distance per time. Therefore, a higher rate is needed to ensure equal coverage of water. Okay, so question 9. On the 1st of April, Kathleen invests £10,000 into a saving account. The account has a normal interest rate of 3%, which is paid on the last day of every month. Caitlin did not plan to make any further payments into the account or make any withdrawals. Calculate the date in which Caitlin will have over £10,500 in her account. So because the interest is being paid monthly and we're given the annual rate, we have to start off by making 3% is equal to 0.03. So that's per year. So we're going to take 0.03 and divide that by 12. Which is 0.0025 percent or per month. So what we're going to have is 10,000 times by 1 plus 0.0025 to the power n, and we're trying to find that is equal to let me put my zeros in the wrong place there, to 10,500. So this is the same as doing 10,000 1.0025 to the power n is equal to that. So we could do this by almost like a trial and error approach. So we could put 10,000 times by, in brackets, 1.0025 to the power, and we just pick a random number. Let's pick 10. And that would give 10,250. So that's not big enough. So I'm going to double that to 20. And that comes out at 1,512 if I put an n of equals 20 into this. So I can just check with 19. And that gives 10,485. So we need at least 20 months. So by trial and improvement, n is equal to 20. So we have to count 20 months from April. So 12 months would take us up to the end of March. Add another 8 months onto that. So it's going to take us up to the end of November. So yeah, we've got all of April, all of May, June, July, August, September, October, November, December, January, February, March, that's 12. April, May, June, July, August, September, October, November is the 20th month. So it's going to be the 30th of November because it's 30 days in November. Calculate the AER of Caitlin's savings account. Give your answers as a percentage to 2 decimal places. So for this, we need to look back at our AER formula right at the beginning of the paper. So we got 1 over IN to the power n minus 1. So there was 1, so I can't remember if it was minus or plus, 1 plus IN to the power n minus 1. So this is going to be equal to 1 plus 3 over 12 to the power 12 minus 1, and it's 3%. So this is going to become 1 plus 0.03 over 12 to the power 12 minus 1. So AER is equal to 0.0304, which is equal to 3.04%. So every room in the roof space of his house has a uniform triangular cross section. The uniform cross section is shown below. The roof is 8 meters long. Calculate the volume of the room. So this is not a right angled triangle, so we have to use the sine and cosine rules. So I need to know. So effectively, we could do an area is equal to a half AB sine theta, which is one of the formulas given above. So what I'm going to do is call this X, and I'm going to find this angle because that's 180 minus 50 minus 35. So this angle here is 95. So the sine rule says that sine of 95 all over 6.2 is going to be equal to the sine of 35 all over x. So this would give x is equal to 6.2 sine of 35 all divided by sine of 95. So again, this formula is at the top of the sheet. So 6.2 times by sine of 35 divided by sine of 95 gives you 3.57. So x is equal to 3.57 meters. So therefore area is equal to a half, and we need to pick two sides which sandwich an angle. So I'm going to do times 6.2 times 3.57, which I've just calculated, times by sine, and then need the angle between those two lengths, which is 50. So I've got 0.5 times 6.2 times 3.57 times by sine of 50, and that comes out as 8.48 meters squared. So volume is equal to area multiplied by length, which is 8.48 multiplied by 8, which gives us 67.8 meters cubed. Evan decides to add a symmetrical roof structure to bring light into the room. The diagram is shown. The diagram below shows a simple design for the roof structure. Of the diagram, so we've got this. So it's a 3D triangle, effectively. so it's Pythagoras in 3D, with the front view. Evan will need to put strips of lead from B to C and from B to F to ensure the rainwater does not enter. Calculate this. So we're looking for this length here, and then we're going to double it. So we know that this bit here is going to be 3 minus 2, so that's going to be 1. Going into the middle there is going to be 1.2, and then coming up the height here is going to be 0.7. So if we do Pythagoras in 3D, so we can say that BC is equal to the square root of 1 squared plus 1.2 squared plus 0.7 squared. So BC is square root of, well, 1 squared is just 1, plus 1.2 squared plus 0.7 squared comes out as 1.71 meters. Needs 2, therefore 1.71 times 2 is equal to 3.423 meters in total. Right. The roof of the structure is to be tiled. For the top edge, Evan has chosen to use half round clay tiles. And we're told that the thickness of the tile is 1.2 centimetres. The cross section of the tile shown below, so we're told that the inner radius is 8. So the tile manufacturer covers all 6 surfaces with a protective glaze. Calculate the total surface in one. So we have to calculate the total surface of this tile. Okay, so let's first off by just label a couple of these surfaces up. So we're going to have A, which is the outside, B, C can be that face, and there's going to be another side down here, which is D. And what we have to remember is that C, there's going to be 2 of them, and D, there's going to be 2 of them. Okay, so B first. This is equal to the arc times the length, and I'm going to call that the inner arc. So the inner arc is, we got equal to pi, we've got the radius, so we're going to do 2 pi r all over 2 times by the length. So this is going to be equal to, these 2's are going to cancel. So this is going to give us pi times 8 times by 30, which is equal to 754 centimeters squared. Next up I'm going to do A, and this is the outer arc times the length, and I can use exactly the same principle. So we're going to have pi times by, this time we have to add the extra 1.2 onto it, so this is going to be times by 9.2 times the length, which is 30, which is 86 7.1 centimeters squared. Next up, I'm going to do D. So D is just the width of this, so it's going to be 2 times 1.2, because there's 2 of them, times by the length, because this is effectively just a rectangle, so that's going to be times by 30. So that's the equivalent of 2.4 times 30, which is 72. So we now have to work out C. So C is effectively the area of a circle split in two. So we've got the C is equal to pi r squared of the outer, take away pi r squared of the inner, and we're dividing each of these by 2, which is the same as pi r squared of the outer minus pi r squared of the inner, all over 2. Which we could also write as pi over 2 r outer squared minus r inner squared. So this will give us C is, well, we're going to need 2 of these as well. So we're going to need I'm going to write the 2 times there. So that would cancel out these 2's. So that would give us pi. The outer is 9.2 squared. Take away the inner, which is 8 squared. And that's equal to pi times 9.2 squared minus 8 squared, which is 64.8 centimeters squared. So now I need to add all my values together. So I've got 754 plus 867.1 plus 72 plus 64.8, which is equal to 1077.9 centimeters squared. Even as bought tiles for the structure, Truffle Tiles makes 2,000 of these roof tiles every hour. They randomly sample some of these tiles to check their quality. Use the following list of random numbers to select the tiles for the sample. You must start with the first number in the list. Explain clearly how you're going to use this number to select your tiles. Okay, so first of all, we need to number the tiles 1 to 2,000. Then what we'll do is move along the list ignore numbers greater than 2,000 and therefore select tiles with that number, and we have to ignore duplicates. So we'd go along and go, well, too high for 3250, too high for 2002. So the first number will be that, and then we'd go to 1, 0, 1, 1, 4, too high, too high, too high, too high, 1, 5, 2, 1, too high, 1, 2, 3, 4, 5, so 1908. But that's too high, a duplicate, so we'd scratch that as well. 769. So we've got 1, 2, 3, 4, 5, 6, and finally we would go 1003. So that's the complete to this paper. Thank you for watching. Please hit the subscribe button and I'll see you for more help very soon.